So I'm going to talk about Chef provisioning a Chef server cluster. I'm Joshua Timberman, and I'm a code cleric. What does that mean? Well, this tweet pretty much sums it up. I cure technical debt wounds, 1d8 lines of code at a time, and I tell bad jokes. But I wrote a blog post last year about what I'm up to lately, so you can go read that, but don't do it right now because you want to hear me talk. So before we begin, I want to talk about what provisioning a Chef server, what a Chef server cluster provisioning means. It means I'm going to run Chef client on a node that is going to talk to a Chef server. That's not the Chef server that I'm building. And it's going to download the cookbooks and recipes that are going to create machines in EC2 that then run Chef client that install Chef server packages that are going to be the Chef server for hosted Chef. And they run Chef server cuddle reconfigure, which internally runs Chef solo to configure the Chef server. So in other words, cue yo-dog jokes. All right, so I have a lot of content and a lot of slides. I'm on slide 9 out of 90, just to give you a heads up. There's a lot of content on these slides. I'm going to make them available, and of course, this talk is recorded. You don't need to watch the recording because you're watching me talk, and plus you're here so you can heckle me in person. That's pretty cool. But there's readmes in the cookbooks, there's information in repositories, and afterwards I will be at the Chef booth over in the exhibit hall to answer any other questions that you have. So, where are we going with this? And why are we in this handbasket? So a little bit of background. Way back in the beginning, when we first started Chef, we had a wiki that described how to use Chef Solo to install a Chef server. I can't see anything because these lights are up, but humor me. Raise your hand if you use this wiki page to install your open source Chef server long ago. I see quite a few hands in the air. Awesome, right? Shout out to Chef Solo. -C, solo RB, there's a JSON file, we got a Bootstrap tarball. So this is also what we used to build this Chef server that was used for hosted Chef, because of course we use Chef to build Chef, and earlier we saw we use Chef delivery now to deploy the corporate site. So we'd really like to use our own products for things. And as it turns out that using Chef Solo to build a Chef server is a pretty good idea, because you don't have a Chef server, that's why you're building a Chef server, so Chef Solo is the thing that you use. And that's encoded in the Chef server cuddle reconfigure. It just kicks off Chef client, and then it runs some recipes that are built in, and boom, magically you have a Chef server. Omnibus is our packaging system that we use to package up all of our server products, and down in the Omnibus cuddle reconfigure code is running Chef Solo. So this is used across all the various Omnibus projects like Chef Server, Chef Analytics, reporting, manage, delivery, and so on. So those all use Chef Solo. However, hosted Chef is a little bit different, and that's kind of the problem. So we use Chef to build hosted Chef, of course, that's awesome, but most of the cookbooks that we use for that were forked community versions for things like Postgres and Nagios and Erlang and Java and all the other things that are in components. We've got Solr and RabbitMQ, and they all have community cookbooks, and we forked those with the knife community site install command long ago. And we developed that in that repository over time, and it's completely diverged, from the cookbooks for those various components that as they've been developed in the community, but also with the code base that was Private Chef and Enterprise Chef. Those cookbooks that are used by Chef Solo in the Omnibus packages are different. So this isn't the same as what our customers use. So it means that we're doing stuff internally that's a little bit different than what our customers are doing, and that creates a cognitive dissonance. So we're planning on rebuilding hosted Chef, and we have a specific use case. So out in Amazon Web Services in the cloud, and you can tell that's a cloud because it's got rounded corners, we have 2 Chef servers. One of those Chef servers is a cluster that is the Chef server that is used by the nodes that are hosted Chef. Right? So the yo-dog jokes, they know no bounds. So hosted Chef's nodes are all going to talk to a Chef server. And then hosted Chef is going to be a Chef server cluster. So it's going to reuse the code that I'm going to talk about in order to build all those various nodes that are going to be out there that are going to be the ones that, if you're using hosted Chef, then that would be the systems you'd talk to and use as your Chef server. How many use hosted Chef? I see 12 hands. Awesome. It's at least 12 out here. All right. So we heard this morning, and you've probably heard over the last few months, that Chef Server 12, that's the current release of Chef Server. There's one Chef Server, and it is open source. And that has a bunch of benefits like multi-tenancy, and you can have push jobs, and it removes that tension between having different code bases between the open source version and the enterprise version. And as it turns out, when we use that same code base for hosted Chef, then we remove those tensions for our internal uses, what we're deploying and what you're using on hosted Chef. So those are all really great benefits for us. But before we can talk about actually having one of those, we should see what installing a Chef Server 12 looks like. So if you go to docs.chef.io, there's an install server page, and it will walk you through the steps. And if you take out all the pros that tells you about why you're running those commands, and you just get down to the basic commands if you're using Ubuntu, you have 3 commands. dpackage-i, the deb file is the omnibus core package for the Chef server. Then you edit the Chef server RB file, and then you run Chef server cutl reconfigure. Right? So if you're running a Chef 11 or Enterprise Chef, you've done these. Maybe some words are different than what I have on the slide based on the differences in those products. But now this is all the same thing for Chef Server 12, no matter if you're using it with behind your firewall. This would be what we want to be able to do for hosted. And we have a cookbook that supports all that. So it's only a single command. Just run chef solo. We're going to ignore the 3 wget commands above there and the curl and make dir, but one command will do that package install, and this will set up a standalone Chef server. But a standalone Chef server is not super awesome if you have high availability concerns. You want to make sure that you can do that failover. You want to have more front-end nodes for scaling out because you have 10,000 clients that are checking in. One standalone server may not be enough for that. So if you need to do a cluster, the docs site say install on the first node is your Bootstrap backend, and you do the package install and you write the configuration and then you reconfigure, and then after the reconfigure step it's created a bunch of files in this etc opscode directory, and you rsync that over to your front end node, whatever your frontend.example.com is, that's like your front end node. And then on your second node, your front end, you install the Chef Server core package and you run Chef Server cutl reconfigure, because now you have that configuration, and now you've got a Chef Server cluster. But hold on, wait one moment though. I want to back up for a moment and look at that slide again. We're going to rsync a directory over. Never mind that we're manually installing a package with dpackage, but we're rsyncing a directory in 2015. We have Chef. Why don't we use Chef to manage the config files? Well, that's brilliant. How would we do that? Well, Chef provisioning is not only going to allow us to manage those config files, but it's also going to allow us to manage our machines that are in our cluster so we can define what that cluster looks like. So I'm not going to go super in-depth on Chef provisioning. John Kaiser's got to talk about that. I think it's tomorrow, but he has way more information in-depth about Chef provisioning. But just as a brief overview, you may have heard of it as Chef Metal, as it was originally known. Now it's Chef provisioning. And it allows you to manage machines like Vagrant boxes or EC2 instances or OpenStack instances or bare metal systems via SSH as Chef resources. And there's various provisioners available. You've got AWS and Azure and Vagrant and Docker and Docker and Docker Docker, because Docker, because we're in the Bay Area, Docker. And those several of these come with Chef DK. You can also install the other ones as Ruby gems, and it makes it really easy for you to be able to stand up and reason about your cluster. So if we take a step back from Chef servers and we look, if you look at this recipe, how many machines do I have in my cluster? It's not a trick question. Yeah, we have 4. We have a database that runs a Postgres recipe. We have a cache system that's running Memcache, and we've got 2 web front ends running Nginx, right? Like super simple. I can look at this recipe and I know exactly after running this recipe how many nodes I will have in my cluster. Chef provisioning extends Chef's recipe DSL. So it gives us a couple methods like with driver that tells Chef provisioning what driver we're going to use to create those machines. And then we can pass in some options for that driver. So we're using AWS EC2 in the top example, and we're going to have an SSH key of HC Metal Provisioner. We're going to use this AMI, which is Ubuntu 14.04 from Canonical, and we're going to make M3 mediums. And this will make M3 mediums from that AMI for every single machine resource in my recipes. And we can also use the Azure driver. We just change the options that we shove in there, and then those machines would be spun up in Azure instead. So bringing it back to Chef Server, we have a lovely diagram that I didn't make because I can't make diagrams this awesome. But we have a diagram that shows we want to have multiple front ends with an HA pair back end for our Chef Server. That's the orange on the right. And then internally, we at Chef, we want to use our products because we think they're pretty cool. And we want to have Chef Analytics for our Chef Server. And so Chef Analytics is going to be is a separate node. So if I were to look at this in a recipe, I've got a back end, I've got a front end, and an analytics. I'm not doing the HA pair because there's more complexity there for demo purposes. So to put it in a diagram, we have these three systems. So in a broader view, we have AWS EC2. It's a cloud. You can tell because it's a teal border. And then my provisioner it's like a brownish color over here in the corner. And we have hosted Chef is the Chef server. So for this example, I'm using hosted Chef to be my Chef server for the nodes that I'm going to build for hosted Chef's Chef server. And then I can also use these same recipes to build hosted Chef. I'll stop. So for my provisioner, it's also my workstation. So I'm going to use Chef DK and Knife to upload what I need to the Chef server. All right, I'm going to Knife upload my cookbooks. And then it's a provisioning node that I'm going to run Chef Client on that's going to run the Chef provisioning recipes. And what that does is, since I told it to use AWS driver, it talks to AWS EC2. And when it talks to AWS EC2, the first one in my list was backend, and I'll get a backend instance, and it's going to spin up that M3 medium instance in EC2, and then my provisioner sits and waits until that's available via SSH. So if you've used Knife EC2 server create, this is the same similar sort of thing, but it's automatically doing this within a Chef recipe. And then when I can SSH to that node will download and install Chef Client using the omnibus install of Chef, and then it runs Chef Client, which will talk to its Chef server to download its cookbooks, and then converge the node. And then when that's done, I'll have a Bootstrap backend, and it will do the same thing for the front end, and then it does the same thing for the analytics node. So Chef provisioning requires a provisioner. So what is a provisioner? Well, that is a node that runs the Chef provisioning recipe. This could be my laptop, which is my example, but it could also be an instance that's running inside your VPC in AWS. It could be another instance that's running inside a private network within Azure, or in your data center, on your OpenStack cluster, wherever it is that makes sense for your infrastructure, you could have those provisioners. Because if you're on a team of like 12 people, you don't want to have 12 people trying to run off of one person's laptop, right? You want to be able to run off something that they can all use. So a centralized provisioning node is generally the idea that I have for doing that. So what it provisions is it provisions machines. And those machines run whatever recipes I tell them to run, right? So in this case, I'm creating Chef servers. And then on the Chef server itself, the provisioner node needs to have its own API client and node object, because the node object needs to have the run list and all that, because it's running Chef. And the API client, because it's creating it's creating instances in EC2, it's also creating their API client and node object. Rather than using the validator client, it's going to create those, so it needs permissions on the Chef server to be able to create those API clients. In order to authenticate with AWS, if you don't provide a configuration to Chef provisioning for AWS credentials, which you can do with that with machine options, it will automatically look in your AWS directory for a config file. This is, if you've used any of the AWS command line tools, like this is Amazon's documented way to store your credentials on your local system. So it will automatically pick those up and use them. This is from the machine options where I've passed in the SSH username and the SSH key name. That's an SSH key that exists on my AWS account in that region, right? So I've already created my SSH key, and then I'm using Ubuntu images, and their default user for SSH that logs in and uses sudo is Ubuntu. Excuse me. Because I'm using a provisioner node that may have been created itself with Chef, I want to have the SSH key that's required so that it can SSH to these machines that it's going to create. So I put those in a data bag item in plain text because it's super secure. But for reals, you'd use something like Chef Vault or encrypted data bags or other solutions. You just have to write a little recipe. I wrote a little recipe in the Chef server cluster cookbook that I'm going to talk about. It says set up SSH keys, and it pulls them out of the data bag item, and then it drops them off in my .ssh directory. And Chef provisioning automatically will use those keys. So the Chef Server Cluster Cookbook is the reference example for building Chef Server clusters. We've had a proliferation of Chef Server cookbooks because for a while the Chef Server cookbook didn't support Chef Server 12. And I didn't help the situation any by creating another one, but the Chef Server cookbook is for standalone Chef servers, and this one is for the multi-node cluster installations. So the way that it works is it takes some configuration and writes it out, and then makes those machines become Chef servers. So I'm going to talk about the way that Chef server configuration works through a combination of attributes and data bags. Now, I'm going to wave my hands and totally cop out on some of the details about how the recipes work, because that's all open code that you can go read, and I've got links at the end. And also, those recipes are work in progress. We haven't added support for HA configurations. So when we do that, we're going to update those recipes, and they'll behave a little differently for supporting HA and all that sort of things. But I do want to talk about some of the reasons why this configuration is done the way it is. So before we go any further, I want to talk about where we're at, what I've got. So I will have since I'm using Chef Server, hosted Chef, I've got a config.rb that I'm using for Knife and for Chef Client. And then I'm going to upload the cookbooks. I'm using policy files, but I'm not going to talk about policy files in depth here. We can talk about that over in the booth later. And I've uploaded my data bags that I'm going to talk about here. And then I've got my AWS authentication credentials in the AWS config, and then I will have my SSH private key in my SSH directory. And that could already exist, or it could come from the data bag. Since it's using a Chef recipe to write that out, then of course it's convergent, and it wouldn't override it if it already existed and had the right content. So here's my provisioner, ChefConf provisioner node. It has a run list that's simply Chef Server cluster provision. And that cluster provision recipe includes some other recipes that you can see expanded there. This is in the backwards order. So we got setup SSH key, setup provisioner, and the cluster provision. So in the Chef Server Cluster Cookbook, there's a bunch of attributes. And there's attributes for the topology and the role and the Bootstrap. There's the Chef Provisioner key name. So you may not want to use HC Metal Provisioner. You might want to use a more descriptive or different key name, so you could change that attribute and have that pick the right key. Then I want to configure the provisioning driver. So I have a driver hash that here has gems that we're going to install and a with parameter. So earlier I had that with driver AWS US West 2. So that's actually going to come from an attribute that I set, so I could change that to different regions in AWS by modifying the attribute using the matrix of Chef attributes, right? So the gems part is where it will install any of the drivers that it needs, and then it will require those drivers within the recipe so that it can use AWS, or I could change that to Azure or OpenStack. Then at the bottom is a hash called machine options, and that just gets passed into that with machine options. So I can modify anything within the with machine options for Chef provisioning, and those are going to vary based on what your provisioner is, and then it would populate it with those values. So the setup provisioner is setting up Chef provisioning. And at the top there, we can see it's going to iterate over my gems, install the gem with Chef gem, and it will require that gem if it has the require key, and then that would be the thing that Chef provisioning is going to use for the instances created as machines. I've got the machine options are going to come from that attribute, and I've got a helper that does some data massage, and then I'm going to pass the width parameter in and the machine options in. And if I hard-coded all this instead of using attributes, it looks a lot like what we saw earlier with those values. The reason to have those be attributes is it makes it easier to override, and we're going to change behavior depending on whether we're building the hosted Chef instances or if we're building the hosted Chef server instances. But theoretically, we could override those attributes, and I know that text may be small in the back, but this is as your provisioner. This could be a role that changes those attributes for things that are relevant for Azure to be able to spin that up. So I digress. I have no idea what that was. So the cluster provision recipe, this is the thing that does all the work. So we've got, it includes the setup provisioner recipe that we just saw. It includes that setup SSH keys recipe that writes my SSH key out. And then I have a directory that I'm going to talk about in a minute that's my stash, where I'm going to stash some files. And then I'm going to create my machines. I've got a Bootstrap backend that's going to use the Bootstrap recipe. It's going to take the converge action, so that means that every single time Chef Client runs on my provisioning node, on that machine it's going to converge it. It's going to run Chef Client. Now, Chef provisioning won't run Chef Client unless it's told to, because it's idempotent and convergent and knows whether or not it needs to run Chef Client on that node. Then after the Bootstrap backend is done, then we provision the front end, and then after the front end is done, we provision the analytics node. So these machine resources end up with a bunch of internal state. So if we look at this in Chef Shell, I open up the Bootstrap backend resource, and we can see action converge there, but then it also picks up from my configuration the Chef server. So you can see I've got a hosted Chef URI there, and some options of what it's going to authenticate to that server, and that's going to be used when that node, when that instance comes up and converges it with Chef, it's going to use that Chef server configuration. Here's where that AWS driver stuff went in. You know, we can see all those values from previous slides that we're going to use at AMI and so on. And then this is my Bootstrap node, so it's going to get the Bootstrap recipe. Then I have some configuration that's in a data bag, because I like to spread my configuration out into various JSON and Ruby hash formats. And there's some stuff in here that is going to be used for future it's future expansion in the configuration for this cookbook, but the relevant things for the demo part are that I'm going to have an API FQDN chef.jtimberman.name and an analytics FQDN analytics.jtimberman.name, and those are the front end and the analytics nodes that will be up and running when the Chef server is completed. So what we do is we load that data bag item, the topology data bag item, and then we do a search for any other nodes. This is in the Bootstrap backend recipe. So we do a search for any nodes that are also backends, and then we grab data about them. And if that's empty, then we're just going to write our Chef servers with information about ourselves. And then we have some VIPs and RabbitMQ stuff. The way that Chef Analytics works is it talks to RabbitMQ on the backend node, so that it can send and receive messages across that pipeline. So it takes all these attributes and data bag entries, and it merges it into the Chef server cluster. So it will just overwrite anything that's default and anything that you've put into the data bag, and it will just create a nice big blob of JSON data that we're just going to put into a template. So I've got a chefserver.rb file. That's the Chef server config. I'm going to pass in my Chef server config and my Chef servers, and I'm going to notify my Chef server ingredient Chef server core to be reconfigured. That's a cat on a goat. So I'm going to render the configuration from this template, and the topology, the API FQDN, those came from the data bag. I've got all this analytics configuration that comes from the data bag, and then I'm configuring OCID, which is the OAuth2 app that so it can talk to analytics. and be able to authenticate the analytics app. And then if you've configured a Chef server cluster before manually, you'll remember you have to write these server blocks. And these server blocks are the things that define the cluster so that when Chef server cutl reconfigure runs, it knows that it has multiple things that it needs to talk to, and it will populate its config files appropriately. Because if you're doing it as a standalone, it just points to localhost for everything. But when you have a cluster, you have to point to the right IP addresses. So when we render that out, we get actual content from the backend node with the VIP. I'm not using a virtual IP. This is just the backend node's IP address. There's a server block with some information. There's my analytics, FQDN, and so on. On the front end, we have not only the backend node, but we also have the front end node. Because the backends don't need to know about which front end nodes are talking to them, but the front end nodes need to know about each other and about the backend. On analytics, we just have a standalone topology, and the more relevant analytics configuration is in this action source.json file, which looks like this. And the main thing there is that we're talking to RabbitMQ. We got automatically generated secrets and some other JSON data that's in there. So let's talk about Chef Server Ingredient. What is that? Well, it comes from a cookbook called Chef Server Ingredient. So what's an ingredient? Well, that's the various packages for Chef Server Core and the various add-ons. So what's an add-on, right? I'm super clever. Add-ons are those additional features like Chef Analytics, Chef Reporting, Chef Manage, Chef Delivery. I can actually say that one now. And what that cookbook does is it gives you a resource, excuse me, for managing the these Chef Server packages and then reconfiguring them with their reconfigure command. So it uses the package cloud repository resource to create package cloud configuration that then will then install the package and then run reconfigure. So it automates these manual steps because running 2 commands is really hard, right? So if I take just the Chef Server ingredient resources out of all the various recipes that are in this cookbook, they look kind of like this. I've got Chef Server Core, I've got Ops Code Reporting, Ops Code Manage, and Ops Code Analytics. These are going to be run on the different nodes, and then they notify themselves to reconfigure. Wait, what if I told you that resources can notify themselves? That's pretty cool. So why would we do that? Well, I want the reconfigure to happen at the end of the chef run on each of these nodes, and I want to ensure that that happens. And yeah, order matters, and I can make sure that the order does all that correctly. But what if I want to, I want to insert things like installing packages or registering with a monitoring tool and that sort of thing? It's easier to ensure that those happen at the end of the run based on a delayed notification. Now, if you use an immediately timing notification on these, then they will update, notify themselves, update, notify themselves, update, notify themselves, and run in a loop forever until you hit Control-C. But I thought that was pretty cool, and it totally worked for the use case. So now I feel like Neo. So the Chef Server ingredient resource uses package cloud repo and package resource for the install action, and it works on CentOS and on Ubuntu, the platforms that we support for Chef Server. And then we have a reconfigure, which has this cutl command helper library that looks up what the name of the package is, Chef Server Core or Ops Code Manage or whatever, and returns back whatever its cutl command is, and then it will execute that on the node. I do this because our omnibus packaging pattern is consistent. We install the package, we write the configuration, and we run the reconfigure command. Those are slightly different words when you look at the different documentation pages, but we've made this experience common across all those packages. So if you remember this, you don't want to remember that. Instead of using the rsync part of it to make this cluster, I'm going to use a feature of Chef provisioning called machine file. And what machine file does is you give it a machine that has the file that you want, and you download that file to your local path, in this case my temp stash, and then we can upload it later. So I'm going to get these ops code analytics files, and I'm going to get these ops code files, because that's all I needed out of the ops code directory, and I'm going to store those on my local machine, on my provisioner node, and then on my other machine resources, I can pass in a files property to those resources that uploads those to the target location on each of those machines. So I've created the front-end machine. It comes up in EC2. It SSHs over, and it says, okay, I'm going to copy these files to those locations. And then it does the package install and the reconfigure step, and it has those already available. If it doesn't have those, then it tries to generate them. And since they're not, that front-end machine isn't the back end, it may not work properly. So now we have all the things we need for the front end to be able to talk to the back end, because those are the secrets files. And same thing with analytics. So I mean, I could totally just put rsync in a recipe, but then I feel dirty for using rsync. And we also have to set up SSH keys between the two nodes, and any files that are in the etc opts code directory would be copied over. We may not want to have that happen. So after I do all that, I've got these recipes. I can run the chef client -c with my config file, and it runs chef client. And then I have machine resources magically converge. So when the machine resources converge, we create the Bootstrap backend off that AMI, right? We saw that. We create a Bootstrap backend node on the chef server. We update its run list, and then we wait for it to be available via SSH. Then we generate the client key, and we create an etc chef directory, and we write out the client key. So I'm not using the validator. Chef provisioning doesn't do that. It does all this. This is why the provisioning node needs to have permissions on the chef server to be able to create nodes and clients. Then it puts the public half on the chef server. It makes that new client able to update the node object. And then it does the Bootstrap like you may have seen, where it creates the hints. It writes out the chef server configuration in the client.rb file. It installs chef, and then it runs chef. And it takes time to download packages off of S3 and run the reconfigure step. And then when the Bootstrap backend is done, then my machine files pick up the files off of that, and then when it provisions the front-end node, it does all those other things, and then copies those files to the front-end node. And so this is the live demo portion of the show, and I'm getting short on time, so I'm going to go fairly quickly. And I'm going to put the wrong terminal up. There. All right, so if I do a knife search, this is talking to my hosted chef organization, and it's going to tell me, hopefully it's not going to time out because I hopefully have network connectivity. Yeah, so I've got some instances, right? I'm not going to scroll up, but you can see there's at least 2 of them there. And then I'm going to go into my handy-dandy browser, and I'm going to go to chef.jtimberman.name, and I'm going to get an SSL error because it uses a self-signed certificate by default. Now you know my email address in case you didn't know it, and you can send me questions. And if you saw the little things appearing on the side, that's manage doing validation, so it's talking to the front-end node to validate that the input that I put in is correct. And I can create an organization. And now I have manage up and running with an organization. On the analytics node, I can start analytics. Here's where OCID comes in, and I can log in with my user I just created. I'm going to authorize analytics, and it's going to take me here, and I'm going to be confused again because it's not showing the full output. It's a little washed out with the monitor. Oops. So anyway, if I download the starter kit to get my key, if I know how to use my computer, all right, unzip. So I'm going to unzip the PEM file and the validator PEM file from the starter kit I just downloaded. I'm going to go into the chef repo, and I'm going to do knife client list. So you can see I'm using my chef server URL is chef.jtimberman.name ChefConf demo, the one that I just created, right? So I'm totally not lying. That's actually working. But when I ran knife client list, I got an SSL error. Because I'm using self-signed certificates and we are secure by default, so in order to not get that error, I need to either create and store valid certificates, or I can just blindly determine that I'm going to trust these certificates are valid and there isn't a man in the middle on the network here, and I'm just going to download them. So now I can do knife client list. I can upload my cookbooks that are in this repository. And I don't think I have time to launch an instance, but we should be able to go back over to analytics and see that there's stuff happening. And we can see that I've uploaded those cookbooks. So that all just happened. So this is talking to this is the analytics node picking up those events on the Chef server through the API. It's picking those up out of RabbitMQ. That's why it talks to Rabbit. And then it's displaying them here. Now, Chef Analytics has capability of creating rules and notifications. I'm not going to go through all that, but I could create a notification that would send a message to HipChat whenever somebody uploaded a cookbook, or send an email whenever a node updates more than 3 resources on a node. Or I can use the audit mode feature and have rules that work with that to send alerts if we're out of compliance with one of our audit mode checks. So, to wrap up, Chef Server 12 is totally awesome, and you totally want to use it because it's open source. It gives you the awesome features of multi-tenancy and role-based access controls. If you have 25 nodes or fewer, you can use those premium features, and they're super awesome. And I think that Chef 12 is what everyone should use, because you should always use the latest version of all the software everywhere, right? The other thing is that using Chef to build Chef is awesome. I love it. Like, my favorite command to run is Chef Client, and as you can see, I ran Chef Client a bit there. And I had Chef Client run Chef Client, which is kind of cool. Because Chef provisioning makes deploying to EC2 easy, right? How many parameters to Knife EC2 server create did I have to look up? And it's kind of embarrassing how many times I have to look those up, even though I've been using it for 5 years, right? It's like all these command line options, and I just put those into a recipe, and now I don't have to worry about it. The Chef Server Cluster Cookbook is a full working example. The code's on GitHub. It's a public repository. We're using it for, the plan is to use it for building hosted, and you can use it to build your own clusters, and it totally works. There's still some stuff that's missing, like HA, but we're going to continue development on that. If you don't want to use that cluster cookbook because you don't agree with a certain way that we went about it, you can always just use the Chef Server Ingredient Cookbook and use those resources. That's what we're using in our QA environments to do acceptance testing of Chef Server clusters where we do our automated tests there. And so you can use a Chef Server Ingredient for your own. I'll be at the Chef booth after this over in the exhibit hall, so if you have further questions, we can do that. Do you have time for questions?
We're going to open up the floor for about 7-10 minutes of questions.
Okay.
So raise your hand, and you can call on you. Come over there.
Is there any, all of these cookbooks seem to reach out to the internet to fetch stuff? Is there any plans to make this work with like local repositories?
So the question is, are there plans to make this not talk to the internet? And actually, not only are there plans, but that code is already in the Chef Server Ingredient Cookbook. So it already does that. I don't remember exactly how to go about it because I trust the internet. It's not a terrible place. But yeah, that use case is something that we have support for. Yep. So it's in there.
Okay. Question over here.
So Joshua, this is Doug. Hey, what's the timeline for HA?
What's the time?
That's what we want that.
I don't have a timeline for HA. I haven't been working on the cookbook itself because I've been writing this talk. Soon-ish, like that would be the next step, because I know that for our QA we want to be able to test HA scenarios that failover works and all that stuff. So I know that Patrick Wright has been working on that in our QA environments. So adapting that to this cookbook shouldn't be too terribly difficult, but I haven't approached it myself. But the HA with this will be using the AWS EBS fencing strategy. I see a thumbs up, so Doug trusts the internet as well, and that's pretty cool.
Okay.
If you don't trust the internet, then I don't know what that would look like or what the time frame would be. So, yeah. Other questions?
Hey, what's happening? It's Trevor from RMS. With the Chef provisioning, I'm curious, is the pattern just to run it once and then your VMs are up? Or can you run it repeatedly and it'll ensure that the VMs are still there, you reconverge them, something like that?
I totally did this last night at the meetup. I reran this. So the way the Chef provisioning works is it takes idempotent actions to converge the nodes into the desired state. The desired state is that I have a machine called Bootstrap backend that is of that AMI and that has this run list, and I have a front end and I have an analytics node. So when I rerun the Chef provisioning recipe, it will apparently take a really long time, so I can hear myself talk some more. It's going to say, okay, I need a machine named Bootstrap Backend. It's going to see that I have a machine called Bootstrap Backend, and it's not going to create a new instance in EC2 because it already has it. And then it'll run through and do a converge. It'll run Chef Client on the Bootstrap Backend because I told it to, right? I said action converge, so that means that yes, I'm going to converge every time you run, right? So it's downloading the cookbooks, and it's running, and you can see there's a bunch of stuff that it's already up to date, like package cloud repo, and then it's running reconfigure with action run, because that's what I told it to do in the recipe. So this takes a little bit, but that is a convergent operation, and so it will finish running, and the state will be how it's supposed to be for that particular node. It'll go on and do that for the front end and go on to do it for the analytics. Now, if I go into the EC2 web console and I kill the front end node and I rerun this recipe, when it comes up to the front end node, it'll say, I don't have that instance anymore. I'll create you a new one, and then it'll create that and converge it, and it will be added. Or if I change the recipe so that it says I want 2 front end nodes, it would create those.
Any other questions?
Thanks. Is this the kind of thing that you could model with Vagrant, or do you have to use EC2 for testing?
Great question. You can totally do it in Vagrant. The thing you have to do is change that with driver and the machine options. And I don't remember what they are specifically for Vagrant, but there is a Vagrant Chef provisioning driver. You could do it for LXC or Docker or Solaris zones if your recipes support Solaris. Like those are all Chef provisioning drivers that exist.
Anyone else? Raise your hand. All right, let's give it up.
Thank you.